Hello everyone and welcome back. I'm Mr. Kovold, and in this video I'm going to continue with the second problem involving partial pressures and mixture of gases. So in this problem we're asked a sample, or we're told that a sample of hydrogen gas is mixed with water vapor. The mixture has a total pressure of 755 torr, and the water vapor has a pressure of 24 torr. What amount in moles of hydrogen gas is contained in 1.55 liters of this mixture at 298 Kelvin? Okay, so they're asking us to find the amount in moles. We want to find the amount of moles of hydrogen gas. Well, they give me the liters, the volume, the temperature, and if I had pressure, then I could use the pressure with the ideal gas law and I could find moles. So they give me the total pressure of the mixture of the gas and water vapor, 755 torr, and they give me the partial pressure of the water vapor. So I can use Dalton's law of partial pressures to subtract out the partial pressure of the water vapor from the total pressure, and that would give me the pressure of the hydrogen gas. So I'm going to start by doing that. So I have the total pressure is 755 torr, and that is I'm gonna subtract out the 24 torr from the water vapor. So the pressure, the partial pressure of the water vapor, and if I subtract that out, then I'm going to get 731. So 731 torr is the partial pressure due to the hydrogen. So, and if I'm going to use the ideal gas law, now I need to convert that to atmospheres. So I'm going to have to, I'll do that down here. So 731 torr over 1. And I know that 1 atmosphere is equal to 760 millimeters mercury. That is also true for torr. So 1 atmosphere is equal to 760 torr. And the reason for that is because 1 millimeter of mercury is equal to 1 torr. So it's the same thing. So 760 torr on the bottom, so I cancel out torr on top. And then I have 1 atmosphere on top. So the torrs cancel out and I have atmospheres. Okay. And so now I can calculate the number of atmospheres. So 731 divided by 760 equals, and I get 0.96184. So I get 0.96, 0.96184 atmospheres. Okay. So now I have atmospheres. Let me check my sig figs. This is going to be exact. 1 atmosphere to 760 is exact. So we don't need to worry about that. So 3 sig figs. So I have 3 sig figs. So the 1 is my last sig fig, but I'm going to keep the rest because I have to do more calculations. I have to put that into the ideal gas law. So now that I have the pressure in atmospheres, I have temperature in Kelvin, and I have volume in liters. So now I can solve the ideal gas law for moles. Okay, so that means, moles of hydrogen is equal to the pressure times the volume divided by the R, the ideal gas law constant, and T. Okay, so now I just plug in the values I have. So pressure is going to be 0.96184 atmospheres times the volume, which is 1.55 liters. So that's 1.55 liters. And then for R is going to be 0.08206 liter atmospheres over Kelvin mole. And then temperature is going to be 298 Kelvin. So 298 Kelvin. And so now I can put that into my calculator. So I have 0.96184 times 1.55 divided by 0.08206 divided by 298 equals, and so I get 0.0609. So that's going to be equal to 0.0965. Oh, and since this is going to be moles of hydrogen, so we can see that the atmospheres cancel out, liters cancel out, and Kelvin cancel out, leaving moles. Okay, so now we have moles of hydrogen, which is what they're asking for. So what amount in moles of hydrogen? And so now we need to figure out our sig figs. So remember, I was only allowed up to the 1 for my atmosphere. So here is the 1. So I have 3 sig figs here. I have 3 sig figs for the volume. I have 4 for my constant, and I have 3 for the temperature. So the least number is 3. So I'm going to have to cut it off at the 9. So 0.0609. I have a 6 here, so that means the 9 is going to go up to a 10. So my final answer is 0.0610 moles of hydrogen. So that's my final answer for that problem. So I hope that was helpful. Again, we had to use the Dalton's law of partial pressures to find the partial pressure due to hydrogen. Once we found the partial pressure due to hydrogen, we could then convert that from torr to atmospheres. And then once we had in atmospheres, we just used our atmospheres, volume in liters, the temperature in Kelvin, and then we solved for the ideal gas law. We solved the ideal gas law for moles. And so that's it. So I hope this was helpful. If you like this video, like it, share it with your friends, subscribe to the channel, hit the notification bell so that way you can get notified of any new videos I put out, and put a comment in the comment section and let me know what you think. Thanks for joining me, and I'll see you next time.